All right, here we go with the product rule. Now, if you've already done the chain rule in class, this is going to be the product rule without the chain rule. I'm just introducing the product rule. If you're having a lot of trouble with it, you might want to watch this anyway before proceeding to the other chapter. But then I'm going to have another chapter called the quotient rule and product rule, only it's going to be with the chain rule. So in parentheses, you'll see with the chain rule. This is the ones without the chain rule. All right, so what is the product rule? As I've emphasized in a couple other videos already, if you see something like this, it's x cubed times sine of x. That's a function times another function, so we're going to have to use the product rule. Same thing here, this times this. Same thing here, this times this. This one's a little bit of an exception because we could FOIL it out and then take the derivative of a polynomial if we FOIL it out first, and I would actually recommend doing that. But point is, if you have two things multiplied together, you can't just take the derivative of one times the derivative of the other. You have to use this fancy thing called the product rule. So here's what it is. If you got the derivative of something times something else, so like here's a problem where we got x squared times 2x minus 6, the way you find this derivative is you take one of them times the derivative of the other, and then you switch. Then you leave the second one alone and take the derivative of the first. So I might label this one u and this one v. So the derivative, f prime, is going to equal, let's see, so first I have u. My u is just x squared. Then I'm going to multiply that by v prime, so that's the derivative of this chunk. Derivative of 2x minus 6, the 6 goes away and I've just got a 2. Then I have a plus sign. Then I got a v, which is the second one. And put that in parentheses always when you're subbing in on these. And then u prime is derivative, so that's a derivative of this first term, which is x squared, so that's be 2x. So at this point it's just a simplifying thing. We got 2x squared here. Then we got to distribute this out, so we got 4x squared minus 12x. Now we combine like terms, got 6x squared minus 12x, and we're done. So for basic ones, I would encourage you just to, of the two things multiplied together, label one v, label one u, and now we just keep track of them and just literally write down this formula and then do it just like I just did. Look for u, look for v prime. If you try and do it in your head, that's just an opportunity to make mistakes. So once you get really good at calculus, you're doing really great, you can start doing more steps in your head or sort of skipping a step. But for right now, I'd encourage you to label them. All right, so we'll label this one u and this one v, and just plug and chug. F prime equals u, so that's the first one, times v prime. Oops, v prime is just 1, so that's pretty nice. Then we add that to v, which is x minus 1, times u prime. So that's going to be 2x plus 3 is the derivative of u. All right, so at this point, once again, it's just a lot of algebra. That's how it goes. X squared plus 3x. This one we've got to FOIL out. So plus 2x squared plus 3x minus 2x minus 3. I figure if you're in calculus, you're probably pretty good at algebra. Otherwise, you wouldn't have made it this far. So 3x squared, then you got 3x plus 3x is 6x, minus 2x is 4x, and minus 3. All right, pretty fun stuff. Once again, something times something. So we'll label this u, label this v. Now you'll notice we have a mix of polynomials and trig functions on this one, but that don't matter. We're just going to plug and chug. So f prime is going to equal u, which is x squared, times the derivative of v, which will be cosine. Then we're going to add v, which is sine x, times u prime, which is just 2x. Now, why did I put this dot in here? It wasn't totally necessary. I just wanted to make it really obvious that, that the x is the only thing the sign is of. The 2x is added on the end if that's multiplied. So you'll notice right now when I rewrite this to sort of make it look better, I don't have any like terms to combine, but I am going to put this 2x out front so it's super obvious that 2x is not part of the argument of sine, so it doesn't look like it's the sine of x times 2x. Because that's the kind of confusion that can mess you up and can lose you credit. All right, yet again, we got something going on. Call one u, call one v, doesn't matter which is which. Now in the quotient rule, it's going to matter which one's u and which one's v, because one of them's going to be upstairs, one's going to be downstairs, and there's going to be a minus sign right here. And obviously a minus b is not the same thing as b minus a. But for the product rule, because it's addition, and both things are going to get, the derivative taken of them, and both things are going to get added and stuff, everyone's accounted for. It doesn't matter which one is u and which one is v. So we got u as sine theta, and then v prime, derivative of cosine, is negative sine. Then we're going to add v, which is cosine theta, times u prime, so the derivative of sine is cosine theta. All right, so we got negative sine squared theta plus cosine squared theta. Aha, I see something. Now bonus points for you guys if you notice this. You remember those double angle formulas in trigonometry? There's two of them and they actually do pop up. So of all the stuff you learned in trig, sine squared plus cosine squared equals 1 is going to pop up a lot, or at least often enough you should remember it. And there's also one which was that cosine squared minus sine squared theta is going to equal cosine of 2 theta. So this is one of those rare times that whatever's behind the argument of the sine or cosine, which in case was theta, 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 becomes 2 theta by using this special formula. So that is awesome. If you wrote that down, you get extra credit probably from your teacher. There will be other problems you just won't be able to finish unless you notice something obscure like that. And just since we're on the topic, the other one you should know, so this is one of them, cosine squared minus sine squared equals cosine of 2 theta. That's one formula you should memorize. And the other one is that 2 sine theta cosine theta equals sine 2 theta. So this will work both ways. You might see this in a problem and figure out you should replace it with this, or you could see sine 2 theta and want to replace it with this. But either way, this is the most common thing, the most common one that pops up in calculus problems. All right, cosine squared. Now this does not look like a multiplication problem. It looks like a power rule with a chain rule thrown on top. But we could rewrite f as cosine x times cosine x, right? Now all of a sudden it looks like a product rule. This is the kind of trickery that you need to do sometimes to get it by in calculus. So once again, we're going to label one of them u, label one v. So u cosine x times negative sine x, times derivative of cosine, which is negative sine x. Then we're going to add v, which is also cosine x, times u prime, which is negative sine x. All right, so we got negative sine x cosine x minus sine x cosine x, which gives us a total. Look at that. These are actually identical terms. So we get negative 2 sine x cosine x. And oh my gosh, do you see what I see? This is that formula I just told you about. 2 sine x cosine x is sine of 2 theta, or sine of 2x in this case. And then since we have a negative in front, it's just negative. All right, that'd be some super bonus if you caught that one. Nice job. I see you out there with your hands raised. All right, so again, we don't always have to use the product rule. Here's a couple where we'll be able to do something with trig, sort of, trig proof type trickery. So the big thing you do with trig proofs, when in doubt, was convert everything to sines and cosines. And that's really what you want to do. So tangent is sine theta over cosine theta, and cotangent is cosine theta over sine theta. So cosine, cosine, sine, sine, everything cancels. What does that leave us with? 1, right? Not 0, because really we replaced all these with 1s. So we got 1 times 1 over 1 times 1 is 1. But that's just f still. F prime is the derivative of this. Derivative of 1, and the derivative of 1 is 0, because it's a constant. So pretty crazy, right? Nice stuff. All right, sine theta times cosine theta. Let's take a look. Because it's on the slide with this title, you're probably guessing this reduces. Let's see, we got sine theta times cosine theta over sine theta. Those cancel, so sure enough, it's cosine theta. And remember, this is still f. We haven't taken the derivative yet. But now we take the derivative, and we get f prime is just the derivative of cosine, which is negative sine theta. Now, if we'd done product rule, we would have gotten the same answer. So if we do u and v, Ugh, that's just going to be annoying. I'll leave that for you for extra credit. Take sine theta, cosine theta, and try and find the derivative with product rule, and we should get the same thing of negative sine theta. And I think that's a good strategy always. Like if you have extra time on the test, when in doubt, if you're not sure if you got a problem right or not, you can always just work it a second way. You know, there's always forks in the road in these problems, but they always lead back to Rome. So if you have an opportunity, a little bit extra time, try working a problem a second way. Or if you can't get a problem, you just can't figure it out, it might be that something went wrong early, and if you just take a different fork in the road, things would have simplified in a different way, and it would have ended up working out. All right, ugly trig example. Once again, u and v are going to be the ticket. The only trick here is that secant and tangent obviously have kind of nasty derivatives. So unless you're an AP, you probably won't see this one this bad, because as I mentioned in the trig video, trig derivatives video, a lot of colleges don't even put these in their calculus class. Anyway, so u and v, we're just going to do these as normal. So first I need u, that's secant, so f prime equals u, which is secant x, times v prime. Derivative tangent is secant squared. And we add that, and what is v? Tan x times u prime. Derivative of secant is secant tan. Alright, so it's not that this is impossible, it's just, there's a lot of writing, I don't know. So we end up with secant cubed x plus secant x tan squared x. So in truth, it wasn't that bad, Where product rules get gnarly is when you've got the chain rule. So if you're at all confused by this, hold on to your hat, because when we do the product and quotient rules again after the chain rule, in a chapter called product rule and quotient rule with chain rule in parentheses, that's when they get gnarly. They get a lot longer. They get a lot nastier. So there's just an intro to the product rule, which on its own isn't bad, but when you combine it with the other rules, like the chain rule, that's when things get kind of sketchy, kind of messy. All right,